Hi, welcome back for some more 8 Caillou action. This one's called Points of Reflection. Point reflection or point symmetry is a basic concept in geometry where a given point, P, at a given position relative to a midpoint Q has a corresponding point P1, which is the same distance from Q but in the opposite direction. So you can think of sort of a line segment from a point P to a point Q, and then you're sort of doubling that line segment. You're extending it in the same direction, but on the opposite side. So I would say, if it helps, grab a piece of paper, ideally some graph paper, and draw a little chart. Pick some test points if you need help visualizing this. The task is given 2 points P and Q, output the symmetric point of point P about Q. So you can think of it like you're reflecting it over the point Q, where the Q is a point of symmetry. Each argument is a 2-element array of integers representing the points x and y coordinates. Output should be in the same format, giving the x and y coordinates of point P1. You do not have to validate the input. So of course you would very much validate input in real life, but we'll play along, right? And so this should be clear. Go ahead and pause the video and draw that chart out if it helps you visualize it. Just make up some random points. Draw one point at 0, 1, and draw another one at 3, 4. You know what I mean? And then Q would be at 3, 4. And so you could imagine the line between 0, 1, and 3, 4, and you're sort of copying that, but you're going to put it to the right of the midpoint, and it's going to go up higher and to the right. So definitely take the time to draw that out if it's not clear. And if there's any trouble after the video, hit me up and I'll sketch something up for you. It seems pretty clear in my mind, but I don't always know where other people are at. So I'll go into a solution. You should have paused by now if you were going to. So first things first, I'm going to calculate some distances in terms of both the x-axis, horizontal axis, and the y-axis, the vertical. So we're working with a 2D plane there. I'll call mine delta x, right? That's going to be the distance between the two x components of the point. And so we know in these integer arrays that the x value comes first and the y value second. So we're going to use index 0 of each array to grab the x component. So in that case it would be P0, right? Would give us the x value. And I'm going to subtract from that Q0, and that's its x value. So in that dummy example I said 0, 1, and 3, 4. If you subtract those, you would get 0 was the first one, minus 3 was the second one. You get a value of -3, right? And so we'll find that the negative's not so important. You could absolute value that to just get the actual distance, but we'll do something clever to deal with that. The order doesn't matter. You should be able to go Q0 minus P0 if you prefer that, but just make sure you keep everything consistent. So same thing for the y component, but of course this is index 1 now, right? And Q1. So now we have two differences. We have an x distance and a y distance. So that's good. Now the point now is to extend those beyond Q. So how do we do that? Let's call it, we're going to start constructing the coordinates of our new point, which we're going to have to return. And they call it in the example here P1. Not the best name, but sure, I'll play along. Remember, you're not bound to use any of these. You could rename Q to midpoint if you want, or anything like that. These are your parameter names to control. You're gonna have to maintain it, not this, but you know what I mean in real life. So make it easy on yourself. You can remember this stuff, and you can forget it and easily recover is the idea. So this new X point, how do we get that? Well, we're going to have to go on the other side of Q, right? So in our example, we were left of Q, right? Our P was left of Q. So now we want to take that same X distance, but go on the right side of Q. And so it won't always be, the left and right can be mixed up. So we just got to make sure we're going in the opposite direction. So to do that, let's take Q0, right? That's our midpoint's X value. And we'll add to that our distance, our delta X, but we're going to say times -1 because it's going to flip the sign. So if you remember when we did our X component in the example, we had -3. And so if delta X is -3, when you multiply that by -1, it's just going to come out to 3, right? So it's going to take the midpoint X value and add 3. You wouldn't want to subtract 3 again because it would just put you back at P, right? We want to get a new point, P1, that's in the opposite direction. So that's why I use this -1 to sort of flip the direction, if you will. And then you sort of copy the same thing for Y, right? So I actually should have called that, we'll call that P1X, that's the X component. I'll call this one P1Y. And we'd say we're dealing with index 1 now, right? Because the second index refers to the Y component. And then we're going to use just delta Y times -1. And again, it'll go in the opposite direction of whatever we calculated up here because this -1 is going to reverse that. And then finally, we have our new points X and our new points Y, and our contract says we have to return that in an integer array, size 2, right? We're not doing any error checking, but I can say return new int, and I'm going to initialize it with those values, P1X, the X value comes first, and P1Y. And I think this will do it. We'll go ahead and run the test. And if what I was saying was confusing at any point, you can always add in print statements, right? Console write line delta X, and you can see these values and then what you're calculating for the new values if you're just not sure why your code is outputting something that it is. So this looks good, and all green, so I'll go ahead and submit, and I'm sure there'll be more condensed forms of this, but I tried to be very expressive here so you could see exactly what I was doing. I was getting an X distance and a Y distance, and then projecting them on the opposite side, in the opposite direction of the original point with respect to Q. So let's get our points, check out some other solutions. And so yeah, feel free to scroll through these and look. A lot of these work, but they're just, and it's okay because this example is so simple, but imagine as you're doing, real work, complicated stuff, do you really want to see a bunch of, letter Q arrays and letter P arrays and math operations? That's why I like the delta X and delta Y. It's just, it means something more to me, and this looks more like gibberish, but that's fine. There seems to be people love those one-liners, right? So yeah, feel free to go through those, see if you can add anything new to your tool belt. And again, if you had trouble sort of visualizing this, let me know and I can draw something up for you. Otherwise, I will see you in the next video. Thanks for watching.